Okay, hello students. At this time, I'm trying to solve more problems on proving identities, trigonometric identities. Okay, so the until last video that I did was we did in the first video 1, 2, the second video was 3, and I think I did the next one was 4 and 5, and the next one was 6. So here now I'm gonna go straight away to the next video to do the problem number 7. So I want you to pause this video for a moment, see if you can do it yourself. Uh, should you begin from right or should you start from left or you want to do both together? So we have a discretionary power to do. What I would do is uh, begin with the left side. So I will call this as the left side. And question is using by using the left side. Question is, are we able to figure out that it's the equivalent to cosecant x? So if I start with this one, what are my options for the first? So just imagine we don't know. I'll just start with this. I want to get this cosecant x. I'll start with this and say, okay, only option I can think here is cosecant can be replaced by. So this can be replaced by 1 over sine x. So that will be sine x. So this will be sine x times, and the other one is cosine square x plus sine x. Okay. Now, in order to simplify this, you see this sine x, which you see right here, we can, and there's a sine x at the bottom here. So this sine x, there's a 1 here at the bottom. So what you do is you multiply sine x right here, and also multiply by sine x. Okay. So that we both have the common denominator. So the least common denominator for both is sine x. So put a sine x at the bottom. And this 1 time cosine square will be cosine square of x. And then plus this sine x and this sine x together will be sine x the whole square, which can be written as sine square of x. And then what it reduces to is you get the numerator as we can use the Pythagorean form identity, which equals to 1 because cosine square and plus sine square is always 1. So we get 1 over sine x. And 1 over sine x by definition, or not the definition, yeah, the definition cosecant. What is cosecant? Reciprocal identity is cosecant is 1 over sine x, or you can also write sine x is same as 1 over cosecant x. And there you go. This is cosecant of x. And if you see here, that was the cosecant x that we needed, and we really got it. And I call this right hand side, and we are done. So that's all you're supposed to do. The question is also, is it possible to get from, if you begin with the right side, and is it possible to get this whole big thing, okay? So you can start with this, and I can write the most here is the cosecant is 1 over sine x. And because there are two parts here plus, so instead of 1, you will replace it by sine square of x using the Pythagorean identity. And then you have the denominator, you can distribute for both. So it's like if you have a plus b over c, then write it as a over c plus b over c. So that way we can write this as uh, sine square of x divided by sine x plus cosine square of x divided by sine x. And you can clearly see one of these crosses out. And what stays here is the sine x, and you can break this cosine square as cosine of x. I'll keep cosine square and then write it as 1 over sine x, and 1 over sine x is, so this is sine x plus cosine of square of x, and that is cosecant of x, and you're done. So that way you begin from right, you start from right, and you can still take left. So this is question number 8. Okay, so I'll start with the left side because the left side has got too many stuff, and the right side is just a fine square. So if I start with the left side, what are my option is replace secant as 1 over cosine t, and so this division line, I'm putting it right here. So that's the main division line, which will be along with the equal sign. And this secant itself is a fraction, so you will write 1 over there. And this cosine is cosine of t. And there's nothing down, so I just put a 1 just to show that we need to do more work there. And the secant, which is right here, this secant radical, I'll replace this by 1 over cosine because secant is 1 over cosine. And now you see this part is cosine t. So let's try to get a cosine t, the second term. So multiply here cosine of t and multiply here also cosine of t. And then you see at the same time there are many things happening here. So let's do only the top part. This becomes equal main 1 over cosine of t minus this cosine, and this cosine will be cosine square of t and divide by cosine of t. And this 1 over I'm writing as it is, and we'll do two steps we can do at the same time. Two steps that we can think of is this part, the cosine is the same. So this is like the numerator. So this part is the numerator. This part is the denominator. So if we have uh, a over b and divide by c, that's the numerator. That's the denominator. So we can always write this keep change flip. So keep the numerator and times this c, which is the bottom, you can uh, write it as multiply it reciprocal. So this thing we can write. Uh, I think I don't have enough room here. Let me see if I can make it on here. I don't know why. Oh, there you go. I think I can. Okay. So this equals. So the numerator this cosine is the same. So that becomes cosine of t, and the top one is 1 minus cosine square of t, and this is the denominator which will be flipped. So I put cosine of 2 and divide by 1. And you notice there is a cosine in the numerator and the denominator which we can get away with. So what I left with 1 minus cosine of square of t. But by Pythagorean identity, 1 minus cosine square is back to sine square of t. The reason is sine square of t plus cosine square of t is 1. So we can always write 1 minus cosine square of t equals sine square of t, and that's the right hand side, and we're done. So this is the problem. Next problem is how do we do problem number 9? So this is problem number 9. Okay. So main thing you see is there's you need to remember the formula a plus b. The whole square is square the first, square the second, multiply the 2a and b and double it. So plus 2ab. So that's all you remember. So I'm going to use this trick here. This is the square of a binomial, or this is a perfect, also called a perfect trinomial. So can I use it here? So there I'm going to write this is like a, and the second one is the p, the blue. So it is like a square. That means I have to square sine. So this becomes sine square of 2. Then I have to square the b, that is cosine square of t. Then in between you have to multiply the 2, this 2, that is plus 2 times uh, sine t times, and then you have cosine. So cosine of t. Okay, so then divide by the, whatever that denominator is, that denominator stays the same. Okay, and then you can rearrange this sine square and this plus cosine square. They together gives you 2. So I'm going to replace that by 2 plus 2 sine t cosine t, and now the denominator that you see, so the denominator that you see, you can use the property a plus b over c is a over c plus b over c. So this will be 2 divided by sine t cosine of t plus the other one is 2 sine t cosine of t and sine of t and cosine of t. And you can clearly see, you can cancel out this cosine sine t and also cosine t. So what are you left with is this thing, this part we can rearrange this part. So this, there is a sine t and cosine t. I can write this as 1 over sine t plus 1 times 1 over cosine t, and this 2 stays by itself plus 2, and the answer will be, using reciprocal identity, this 1 over sine t will be cosecant t, and this 1 over cosine t will be secant t. And that's what you wanted, right? And that's called the right hand side, and we are done. Let's go to problem number 10 next. So I'm going to start this one, problem number 10, with this thing as the left side, and can we get the right side? So what are my options here is, we can replace cosecant as 1 over sine, and cotangent we can write cosine over sine. So that's what we are going to use. So because of the rule I'm writing here, so this is the main division line I'm going to write here, main division line, because the 1 will be a little up here to make a room for fraction, because this 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 cosecant square, this cosecant square we can write 1 over sine square of x. Okay, then the down part, cotangent square can be written as cos square of x upon sine square of x, and then there is a plus 1. Okay, now you need to do some work here. So what this basically means, if you have, this is like a 1 here, and there is a 1 here. So somehow you want to have, instead of this, I'm going to write, yeah, we can do right here. There's a sine square right here. So take this 1, and I'm going to write this as 1, and this side you multiply and divide by sine square of x and sine square of xy, so that they have the same denominator, this one and this one. And in this example, you see there's a 1 here, and here there is a sine square, so we can multiply here by sine square of x over sine square of x. And then what this one will stay, and this will be sine square. At the same time, okay, let's do it. So let me see if I can make a room there and write this step equals, see, so I'm going to write a big division line, and this one has both have the same sine square of x. The top one is sine square of x plus 1, and the down, this thing will have the same denominator, sine square of x, because here it is. And the top is, so the top will be this cosine square and this sine square, so it's become cosine square of x plus sine square of x. Okay, and then you see this denominator and this denominator is the same. There's a trick here you can use. If you have a over c and then b over c, you can just cross it out. That's because this is a over c, and keep change flip. So this B over C becomes C over B. Eventually that C crosses out, you get A over B. So in this example, we can directly cross out this and this crosses out. So what I'm left with is, so you're left with sine square of x plus 1 up, and the down one is cosine square. But the moment you see, when you look at it itself, you know that the denominator is a Pythagorean. You can use Pythagorean identity, which is cosine square plus sine square is 1. And and that's all we wanted. Okay. So that's all we wanted. So this is same as this one. We are done. Let's go to, okay, the next one is question number 11. So again, I'll start with, because this looks a little hard. So let's start with this at the left side and replace cosecant. So you have all of them to be changed. So cosecant is 1 over sine, secant is 1 over cosine, then tan is sine over cosine, and cotangent is cosine over sine. So let's use that substitute. So this I'm going to make it room here to write down equal sign, big division line. This cosecant is 1 over sine. I think it is x, right? This is x. And this secant is 1 over cosine. This cotangent is cosine over sine. And this tan x will be sine over. So that's the first step, to replace all those ratios with the sine and cos form. Okay, then you can use another trick we can use is, so the trick goes like this. If you have A over B plus C over D, you can use cross product. And at the same time, you have to multiply it. Maybe it is A, D plus B, C, and then the denominators are multiplied. So we can use this trick right here. So I'm going to write the denominator. Let me take this off and see if I can. So this will be, yeah, so you're going to multiply this thing and this thing. So that's the main division. Let's put it, this is the main division line. So 1 times, because that will be cosine of x. And then the next one is, let me use blue color. This also will be plus sine of x. And then the denominator will be this sine x and cosine x. So I get sine of x and cosine of x. The same thing you do, this multiply, cosine times cosine is cosine square of x. Then you multiply this to sine square of x. And the down is you multiply this to sine x and cosine of. And then you can use the other trick that I showed, that you can always, so this thing, this denominator and this denominator is the same, so you can just cross this out because it's the same thing. So what are you left is cosine of x plus sine of x divided by cosine square of x plus, but then you see the denominator is already, this is a Pythagorean identity where the answer is always 1, so you get cosine of the numerator and the denominator reduces to 1, and that's all it is right here, which is the right hand side, and we are done. Okay, this is question number 12. So we'll take the difficult one. So that looks very difficult. So that's called left hand side. Okay. And then question is, do we write, of course, I'm not saying you can always write this secant as 1 over cosine. And this is sine over x. You can do this way. And the other one we can use 1 over cosine and get this answer. But is there another shortcut? As we progress working on a lot of identities, we should think of more identities that we know. Let's see, the other Pythagorean triplet we know is 1 plus tan square x is secant square of x. In other words, secant square of x minus tan square of x equals 1. And you notice that there's a secant x plus tan in here, and there's also secant x minus tan x. So if you multiply these two, this should work in your mind. You must be thinking, hey, can I get it like a plus b, a minus b? The difference of square is a square minus b square. So somehow our goal is to get this. Let's check it out whether that works. So I'm going to use the cross product trick. So this part will multiply here, and so it's 1 times. So this secant of x minus tan of x. Then plus, I'm going to use different color now. Let me say this one, this, and this will multiply together. You remember the cross product? So that's the secant of x. I don't have to worry about the parenthesis here because you have a plus sign there. So this one is plus. So this is plus, so don't worry. And the denominator, you need to multiply this too, right? So that's like secant of x plus tan of x and secant of x minus tan of x. And there in the numerator, you can clearly see we can cross out that this tan x and this plus tan, there are two secants, they will combine to 2 secant x. But the denominator is of the form a, and this also is like a, and the other one is b, this is like a b, so this is b, so this also is b, so the formula is like this. So you have a plus b, a minus b is a. So you square the pink, that means you square the pink, and then minus you square the black. That's the b, right? B is 10, b is 10. So that's 10 square of x. And then you can see now, hey, that's the formula. The Pythagorean identity says the denominator is going to be. So let me wipe this off. So the Pythagorean identity, this equals 2 secant of x stays the same, but the down is 1. And that's what we got, 2 secant of x. And there is the same thing. So we wanted to make sure we get the right hand side. That's the right hand side, and we are done. Okay, the left side looks pretty little difficult, so we'll begin with the left and check whether we are able to get the right side. Okay. So the question is, what do we do here? We can use the same idea as use uh, cross product. So this thing will go and multiply to this one. Let me be sure I'm using some color for this. Maybe blue color. So this numerator go multiply this denominator. They are the same because it's the same 1 plus cosine, 1 plus cosine. So we can write this as 1 plus cosine of x, the whole square, and minus, and let me use the red color. This one and this one gets multiplied. So it is 1 minus cosine of x, the whole square. And then the denominator is, you multiply this together, this denominators are multiplied. That means it's 1 minus cosine of x and 1 plus cosine of x. And for the numerator, The numerator will be, we have to use the a plus b, the whole square, which is square the first, square the second, and in between you multiply the 2 and double it to ab. So that's what we have to do two places here as well as here. So the first one is, so this is like your a, that's like a b. So you square the first, which is 1 square, square the second, which is cosine square of x, and then multiply this to 1 time cosine and double it. So you get 2 cosine of x. The second one is, because there's a minus, you have to write the parenthesis. Square this, so 1 square. Now there's a minus, so the minus stays, so 2 times 1 times cosine, which is cosine of x, and square the cosine, so that's cosine of square of x. And the denominator is of the form a minus b and a plus b, which is a square minus b square. So that will become 1 square minus cosine of square of x. Now we'll try to open this, just like multiplying 1, use the negative property. That's if we have a minus, if change all the sign. So this will be equal to big division line. And this, the down part is almost like 1 square. This is 1 square is 1, and 1 minus cosine of square is sine square by Pythagorean identity. Now let's write this exactly the same. This stays the same, but this will be 1 square is 1, but because of minus, I put minus. This minus will change to plus, to, and this plus will change to minus. And let's cross out anything that can be cancelled. So this will be, this cosine square goes away, this one goes away, and this 2 cosine x will, and I think I did forget to write the denominator there. Somehow I forgot this one. This 1 square minus cosine is sine square x. So what I left with is this together will be 4 cosine of x divided by and sine square of x. Okay, and so we need to prove that. Okay, so now we're almost done. So this equals, and we'll try to rearrange some terms. Let's see why. Cosine of x, and I'll try to break this apart into sin x, sin x. One of the sin x I'll write below cosine, and the other one I'll write it as it is. So now you know what was the reason is this cosine over sine, that will be cotangent of x because of the property, reciprocal identities. And this is cosecant of x. And if you see this, that's what it is. We're done. And we have the last problem for the day. Okay, this is problem number 14. We will start with the left side. So let me begin with this as the left side. So I'm going to write, okay, 1 minus cosine of alpha divided by sine alpha. Notice that in the right side, you need to get somehow this 1 plus cosine alpha. So I'm going to use that trick. So because of this, so I'll just multiply. Okay, let's multiply up down by 1 plus cosine of alpha, 1 plus cosine of alpha. And this is 1 minus. So the top part is clearly see this is like A and this is B. So we can use this. We can use the trick that is plus B, and A minus B is A square minus B square. So we can use that. So this becomes equal. I'm using the blue color for 1 square. That's A square. And then minus, then we have to use B square, and the B is the red color. So I'll use cosine square of alpha. And then, So the denominator is sine alpha stays the same and 1 plus cosine stays the same. Okay, we almost, now this 1 square is 1. 1 minus, okay, that stays, everything stays. The only change actually, I don't know, there was no need to write this step. You can directly write, watch this. 1 square is, I can replace this as by 1. This is 1. But then we have this as 1 minus cosine square. That turns out to be sine square alpha because of Pythagorean triplet. So sine square plus cosine square is 1. So this also is true. So therefore, so the bottom part will be, this stays the same. So that's sine of alpha. And you can clearly, you already done. Now that your mind must be working so quickly, and you say, hey, we can just cross that out, right? So yeah, we can just cross it out. I use the black color. And then say, hey, this sine of 1 alpha, there are two of them. So I just cross out the two. What basically is sine square alpha is, it means there's sine alpha times sine alpha twice. So one of them goes away. So one of the sine alpha stays and you get 1 plus cosine of alpha. And that's right here, and you're done. Okay, question number 15. Now the question is, where do we start? The left side has a sine cos, so should we start? No, I think I will start with this one because there's a cot. So let's write cot over 1 plus 1 plus cot. So we can replace cotangent as, so cotangent is, so what is cotangent? Cotangent is cosine of the angle divided by sine of the angle. 1 plus cotangent again, cosine of the angle over sine of the angle. Now, in the denominator, you see there's a 1 here. This is sine, and we need to have a same sign of common denominator. So you just can't divide, you have to also multiply by this, right? So that way, this stays the same, cosine of this divide by, now I'm going to use now that we have been advanced, this is the numerator, this is the denominator, right? This is the denominator, and that's the numerator. So it's always like keep change flip. So I'll keep the numerator as cosine this one. This division sign changes to multiplication, keep change flip. And at the same time, your work, this part will be, remember there's a sign here. There's the sign here with the common denominator sign. That goes up. And this thing will go down, sign of. Okay. And look up for anything that you can cross it out. You can see this sign and sign goes away. So what are you left with? Cosine this over plus. And that's what we have here. But the question is there another easy way to do this? Okay, that's the very easiest way to do, I'll show. Now let me take this off. And the easy way is, let me start with the left side. Okay, look at this, it becomes so easy. If you want to get from left to right, right? And the right side is a cotangent. You know, cotangent is cosine over sine. So there's all in this case the numerator already has a cosine. So what is missing is, so I'm going to write cosine. This is cosine, and this is sine, right? So what I'm going to do is just divide both numerator. That's so you divide here everything divided by cosine. Okay. Now why we can do this is because if we have a over b plus c, we can always write a over d and b over d and c over d. Always true. And now you see this crosses out and you get the top part cosine. Did I make a mistake here? Oh, sorry. You were supposed to divide by sine. I'm so sorry here. So you were supposed to divide by sine W, sine W, and sine W. So that way we can cross out the blue color. This goes away. Okay, so not this. And this thing is cosine, cotangent. This thing is again cotangent. And this goes away, so you get left with only one, so you're done. It's the same thing. So two different strategies you can do, either go from left to right. So with this, I want to end my video. We did this problem. This video was problem number 7 all the way to 15. And then I will continue doing, I don't know how far I will go, but I want to do as many as possible of this video. Thank you so much for watching. Appreciate. No, yeah, my handwriting is not good. When I write on the board, it become better. But I'm writing with the stylus on my laptop, so it's not good. Thank you for watching.